Okay, so we are checking out organic functional groups. This relates specifically to the New York State Regents exams and questions that come up. You have 3 reference tables, and there is this organic functional group reference table R, that you should have open when you go through questions like this or questions that come up on the test. All right, so let's take a look. The first thing you have to be able to do is identify what functional group you have. And if we take a look here, it's the elements other than carbon and hydrogen. And right here, we have 2 oxygens. So you go to the reference table. There are only 2 groups that have 2 oxygens. And it's either going to be an organic acid or an ester. The difference is an acid has an H on the end, and it can only be on the end of the molecule. And for an ester, it doesn't have to be, well, it won't be an H, it'll be carbons and hydrogens on both sides. Let's go back. That makes this an organic acid for number 1. If I go to number 2, the first thing you want to recognize is you have 1 oxygen. Now, these are condensed structural formulas. In other words, they've collapsed the bonds around the carbons. And you'd have a carbon with your 3 H's. Then you see CO, so you always have carbons bonded to carbons. But then it's an oxygen. If you only put 1 bond, then this carbon in the middle only has 3 bonds. Every carbon gets 4. It's going to be a C double bond O. So the condensed formula for that is just CO. If we go back to the reference table and take a look, 1 carbon, here's your group. And since you have carbons on both sides, you're talking about a ketone for number 2. Let's go to number 6. You only have 1 oxygen. So again, you're looking at that set of 4, but notice you have an H. So if I go ahead and I start drawing it out, I have 3 H's here. Then the next carbon, I have a CH, and then an O and an H. That makes this an alcohol for number 6. And then for number 7 again, take a look. This and this match. Once again, for number 7, you have an organic acid. Okay, let's check out some more. If you don't have this paper in front of you, you could always pause the video and try it on your own. Let's do this. All right, for number 3, again, I have an OH, that's 1 oxygen, and an H. Again, if you don't know, here is my set of 4 that only have 1 oxygen, and here is the OH. It's, again, an alcohol for number 3. For number 4, I have now an oxygen, 1 oxygen, but you'll notice this is different, for example, than number 9. When you see a C and then an O, that's C double bond O, this is a ketone. When you see just an O, well, that's different. Okay, you're going to have a carbon bonded on each side. So I have C, C, then an O, then a C. Remember, oxygen forms 2 bonds. Carbon is 4. If we take a look here at reference table R, our 1 oxygen molecules are here. Well, where do we have an oxygen in the link in the chain? That is an ether. The answer then for number 4 is that it's an ether. All right, moving on. Number 5, take a look. You have 1 oxygen, but notice this time you have H before the O. If it was O and then H, it would be like number 3, which is an alcohol. But it's not, it's H then O. What you have here, let's draw all the carbons in, is you have C double bond O and then an H. This, if we take a look at reference table R, is for an aldehyde. And then finally in number 10 again, notice I have carbons on both sides and then just an oxygen without anything else. That again is going to be an ether. This looks just like this one.
Before we move on, okay, here are all of the structures drawn out. Pause the video, take a look, draw them out. Don't just look at them and say, okay, yeah, I got it. You actually have to do the work. Draw them out. Make sure that you can do this again, whether it's for a test, quiz, etc.
Okay, moving on. Okay, now we're asked to draw structures. Well, we handle this just like we did the hydrocarbons. We're going to go from right to left. Of course, this first one tells me it's an acid, so I have an organic acid, the oic ending, and then but means 4 carbons. So I'm going to draw in my 4 carbons, and the acid is always on the end. It's a C double bond O with an OH, and then I go ahead and I fill in. Remember, every carbon atom gets 4 bonds, so double check it. For the regents, you could leave off all the rest of the H's as long as you have the lines, right? Otherwise, you would draw in all of the H's here that go along with butanoic acid. To get through this quicker, I'll leave them off, but make sure, again, that you at least draw the lines to indicate that an H goes there. All right, let's go to number 2. I have methanol. All right, so what does the AL ending tell me? If I go here to the reference table, remember, as I go through the different compounds, we're given examples. And with those examples, we're given names. The AL ending shows up with aldehydes. With aldehydes, I have a C double bond O on the end of the molecule. Let's go back. Meth means 1 carbon. And here I have a C double bond O. And then carbon's used up 2 of the 4, and it has 2 H's left. Just put 2 other H's here, and that would be known as methanol. Now, let's compare that to number 3, methanol. An OL ending, if I go back to reference table, R shows up here with an alcohol, meaning I'm going to have an OH group. All right, let's go back. For methanol, meth means 1 carbon. I'm going to put in an OH, but remember, we're not done. Carbon has 4 bonds. We've used up 1, so I have my 3 hydrogens. This is known as methanol. So notice the difference. Methanol versus methanol. 1 letter changes the molecule entirely. All right, on the other side here, let's go to number 6. We got methyl methanoate. All right, this is a funky ending. Let's go to reference table R. The O8 ending shows up down here for an ester. And notice that an ester has 2 oxygens. Only esters and organic acids have 2 oxygens. So I have, instead of methyl propanoate, I have methyl methanoate. The prefix tells me what is going on the short end here to the right, and the prop was the 3 carbons and the 1 carbon with double bond. In the case of our example, then they're both methyl groups, they're both 1 carbon, so we're going to have C and O. Let's just go back and check, right? C double bond O though also, so we have C double bond O. For this first carbon, we've used up 3 bonds. Here's an H, and then we have a link, and then the other the other C with all the H's. For pentanol, OL ending, if you don't remember, you take a look at reference table R, is an alcohol. Pent means 5 carbons. 1, 2, 3, 4, and 5. 3 tells me that it's on the 3rd carbon, and we're talking an OH group, but don't forget every carbon atom has 4 bonds, so I have to draw in all the other bonds. There we are with 3 pentanol. Let's go down to methanoic acid. Oic acid means I have an organic acid. Now, meth means 1 carbon. A lot of times, instead of drawing the C double bond O OH, I can just draw it as COO. OH. That's the condensed formula for an acid. Since its carbon is double bonded to O, and then the other O, the only thing left would be one hydrogen for methanoic acid. All right, for number 4, we're taking a look at an ONE ending. So butanone, if I go to reference table R, right, my ONE ending is all the way here on the right with pentanone, and I have a C double bond O. I'm dealing with a ketone. With ketones, I have C double bonds O in the middle of the molecule. So for butanone, but is 4, and then it can't be on the end. It would be an aldehyde. So I'm just going to use it. It could be in any of 4 spots. I could have put it where I drew it. I could have put it here. I could have put it here. I could have put it here. Same thing. Because a flip or a bend, right, in a molecule, it's the same thing. Now, I'm not done, of course, because what do I have to do? I have to draw in all of my hydrogens. Well, how many bonds? Again, for carbon, it's 4. So make sure you draw at least your lines. Oop, do I need one on the carbon with a C double bond O? The answer is absolutely not. It's already used the 4 bonds, and here we go. Okay, so butanone is C double bond O. Now, it's not called 2-butanone. It doesn't have to be, because it can only be in one of those 4 spaces inside of the molecule. It's not long enough. In fact, let's go to number 10. 10 is another ketone. But now we get the number because, of course, with pent being 5 carbons, it could have been on the 3rd carbon or the 2nd. I draw out my 5. I put C double bond O here on my 2nd carbon, and then I'm going to fill in the rest with hydrogens. Okay. Now for number 5, diethyl ether. That's tough to say, right? If I go back to reference table R, our ethers are here. I have an oxygen that has carbons on either side. Remember, it's part of the linkage. And look at the example. You have methyl, which is 1, ethyl, which is 2, ether. Let's go back. And we have diethyl ether. I have my oxygen, and I have 2 carbons for ethyl on the left and 2 carbons for ethyl on the right. And then I'm going to fill in all my carbons with their 4 bonds for diethyl ether. Okay, one more on this page. That's propanol. The ending AL, we go back, tells me now the AL ending. I got to go down. Start with your examples here, right? Because you have your names. You have an aldehyde. That's a C double bond O on the end of the molecule. All right, so for propanol, 1, 2, 3 carbons. I have a C double bond O and an H on the end, and then I just fill in the rest of the carbons, right, with my hydrogen bonds. Now, through this whole thing, I've been saying, oh, it's 4 carbons versus 3, etc. Remember, you have reference table P that gives you the prefixes and the names that tells you the number of carbon atoms. So you always start with that. That's like your backbone, and then you go ahead from there. Whether you're dealing with table Q and just carbons and hydrogens, or you're dealing with R, because now you're dealing with other atoms besides carbons and hydrogens. It's your turn to try. Pause the video, grab a piece of paper, pen, reference tables, and you try to draw out the structural formulas for each of these. That's the arrangement of the atoms, right, with the bonds. One thing to note is 1,2-ethane diol. Di means 2 OH groups. That is not on the reference table. It's just on the reference table as an alcohol. They used to ask that on the old Regents exams. They haven't asked that in a long time. So if you want to skip that one, you can. Okay, finishing out this page, we just have a couple more. Once again, it's up to you. The tri-ol is an old question from the Regents. Tri meaning 3, OL meaning OH groups, 1 on the first, 1 on the second, and 1 on the third carbon. Pause the video, do them for yourself, and come on back for the answers. Okay, here are all the answers. You'll notice that I went ahead and either underlined the keyword or circled the ending or underlined the ending so you know what group it's from. Always have reference table R open as you attempt to draw these, and you might have to practice and do it a couple more times to make sure you got it, but you can do this. So far, we've identified functional groups, we've drawn out the structures from the names, or we've drawn out the structures from the condensed structural formula. Now we're naming. Real simple. You count the number of carbons. You got 2. The prefix is Eth. If you forget, look at reference table P. And I have 1 oxygen, and it's an OH. Well, I can go to reference table R for 1 oxygen. Remember, we're using just these 4 are our choices, and you'll notice the first one, we have an OH. And when I have an OH in a molecule, I'm going to have an OL ending. So let's go back, and we have 2. So this is ethane, not ethane. We drop the E, and we name it OL, ethanol. Now I don't have to name it 1 ethanol, because this OH group, anywhere on this molecule, if we swapped it out with a hydrogen, it'd still be ethanol. All right, let's move on. Let's look at the one below. I have a 3-carbon chain. That would make it prop, and I have a C double bond O. So I have 1 oxygen double bonded to a carbon in the middle. If I go to reference table R again, when I have a C double bond O in the middle, I have a ketone. That means I need the ONE ending. I go back, and this is going to be propan, not propane. I drop the E and make it ONE, propanol. Again, do I need to say it's 2-propanone? The answer is no. With these short chains, you don't need the numbers. Let's keep going. Alrighty, in this next molecule up here, we have 2 oxygens now. We have a C double bond O and O in the middle. We have carbons on both ends. Let's go to reference table R, and always use the reference tables. Don't do this off the top of your head. There's no reason to. You have the table at your disposal. I'm going to go ahead and clear this, and let's roll on down. All right, we only have 2 categories for 2 oxygens. That's our organic acid and our ester. And right away I can tell you, it can't be the acid because I didn't see OH on the end. So we're dealing with an ester. Okay, naming these things for the entire reference table R is probably the most annoying, but we can do it. For the carbon double bond, right, and the rest of the carbons to the left, that's where the prefix comes in with the O8. So let's go back. All right, let me clear this for a minute. So here we have the carbon and the double bond O and 1 carbon to the left. So this is not ethane, but ethanoate, ethanoate, ethanoate. And then what do I have? To the right of the oxygen in the chain, I have 1 carbon. That's meth, or methyl really. So it's methyl ethanoate. Again, a little annoying, but not impossible. Follow reference table R for your example. All right, and the molecule below, life is good, life is easy. I have 4 carbons, that's bute. Now I'm not going to call it butane. I'm going to drop the E. I have an OH group, butanol. It's an alcohol. However, this OH group, if it's on the first carbon instead of the second, that would be an isomer, right? Same number as carbons, hydrogens, oxygens, different position. We're going to call this 2-butanol, because as soon as you get to 4 carbons or more, usually you have to give a number for the position. All right, let's finish this out. All right, for this next one, I see 4 carbons. So that's going to be a bute. That's not going to be butane. I have a C double bond O and an H, so 1 oxygen with an H on the end. I go to the reference table, and let's see. Here is 1 carbon only, and my C double bond OH is an aldehyde. Play the matching game. I need an Al ending. Let's go back. So this is going to be butanal. Any aldehyde, you never need a number in front, no matter how long the chain is, because the C double bond O is on the end of the molecule. All right, if I go underneath, I have 2 carbons. That's eth, typically ethane, but I have 2 oxygens now. And if I go to the reference table, it can only be an organic acid or an ester. There's an H with the O, that makes it an acid. So it's oic acid. So let's go back. So this is not ethane, this is ethanoic acid. Again, I never need a number for an acid because you're dealing with the functional group on the end of the molecule. For the third one here, I have a carbon, then linked to oxygen, and then linked to another carbon. Well, let's take a look. We're talking 1 oxygen. Doesn't look like an alcohol. Oh, wait a minute. It's an ether, isn't it? Because the oxygen is part of the linkage. And when you name ethers, you're just dealing with, notice, the prefixes for the number of carbons before the word ether. If we go back, we're dealing then with 2 methyl groups. I could call it methyl ether, but usually we use the prefix di to mean 2, so this is diethyl ether. Alrighty. Finally, let's finish up the last 3. We have a C double bond O OH. 2 oxygens. If you don't recognize it yet, even if you do, go to reference table R. I only have 2 possibilities here, an acid or an ester, or C double bond OOH is an acid. So this is definitely going to be an oic acid for the ending. And there are 3 carbons, so this is not propane now, but propanoic acid. Next one, I have 1 oxygen, C double bond O and an H on the end of the molecule, and I have 2 carbons. This is not ethane. I'm going to drop the E. I go back and take a look. I only have these choices here. Oh, nope, right there. Doesn't look like an alcohol. Doesn't look like an ether. Oh, wait a minute. C double bond OH is an aldehyde. You got that Al ending again. So this is ethanal. Al. And finally, for the last one, I have 4 carbons. It makes it bute. It's not butane, but I have a C double bond O now in the middle. And if I go and take a look, oh, wait a minute, C double bond O in the middle was the one right below. That's a ketone. So butanone. Now, for this one, I don't need the number again because only starting with 5 carbons in a row can the position change, because I could have had the C double bond O where it is, I could have had it down here, I could have flipped the molecule and had it here or here. All right, so that is functional groups. I hope this helps. Keep working hard. Good luck.